Okay, good afternoon. My name's Keith Mitchell. As you probably gathered, I'm not from around here. The weather, at least, is familiar. Anyway, I'm going to be talking to you today about something that I've had a lot of experience about, which is running internet exchanges. I hope that this information is useful or at least enlightening to you. I'm going to cover a few topics, just a little bit about myself, some basic principles of how do internet service providers interconnect with each other on the internet, a little bit about the history of internet exchanges, a little bit about the models for building internet exchanges, how they're operated, how they work technically and operationally. Talk a little bit about internet exchange security. I think there's some interesting topics there. How to set up your own internet exchange. And a little bit more, I think, particularly relevant to perhaps the audience here is some background about regional internet exchanges. A little bit of my background, summary. I've been doing this internet operations stuff for far too long. The current thing that I'm doing is running a body called the UK Network Operators Forum. It's very similar to NANOG, if you've come across that in North America, a British equivalent of that. What's new with me? Well, I've just moved to Cleveland, Ohio. I was good enough to get a job here, and now it's time for a change of scene. So here I am. Please do let me know if I use any phrases or say things in a way which isn't clear, either from a technical or cultural point of view. Internet interconnect principles. What happens at an internet exchange point? Basically, at your typical internet exchange, there will be a bunch of internet service providers who will have equipment, routers in the same building, which will be a data center, usually operated by a company that builds itself a co-location provider. Within that building, these ISPs connect together. Sometimes they will run a direct wire between them. Sometimes, more commonly, there will be a shared interconnect fabric, which is usually one or more Ethernet switches. The exchange routing information using BGP, Border Gateway Protocol. The exchange of the routing information leads to the exchange of traffic, and that's done on a bilateral basis. So pairs of ISPs will decide, we're going to here, we're going to exchange traffic, let's set up a BGP session. Sometimes the exchange operator who actually operates the cloud of Ethernet switches will be the same people that own the building and operate the building. Sometimes it'll be a different organization. The people that own the building, colo provider, they'll have lots of different customers, ISPs, carriers, content providers, people running portals, content distribution, name registries, all kinds of things. So what are the advantages of an internet exchange point? It's very simple. It's one place where you can connect everybody. So you run one big fat pipe to a central location. There's lots of other people do that. You get economies of scale. You don't have to route your traffic over lots of bilateral expensive circuits that go one to each of the other ISPs you need to exchange traffic with. In more detail, commonly the motivation for setting up an internet exchange is to keep the traffic within a region, so that within a country you don't have to go outside of that country and back in just to talk to somebody who's in the next city. Within a city you don't have to go over to Washington DC and back and talk to somebody who's just down your road. The numbers vary. But typically, anywhere between a fifth and a third of the traffic can be local. For some parts of the world, and Korea has actually got the biggest internet exchange in the world because they have a lot of local content that is of less interest to the rest of the world. What are the other advantages? Reducing your bandwidth cost. If you take that traffic off your expensive long-haul circuit, that frees up more capacity. It potentially reduces the bill to the upstream ISP that you're buying transit from. Local fatter pipe are cheaper on a local basis, so you've got more bandwidth to play with. You're not hopping through lots of indirect other routers or other locations, so it's very good for improving latency as well. There's economies of scale. As I said, the basis that internet service providers generally exchange traffic at an exchange is something called peering. I'll say a little bit more about that later, but the main motivation is it saves you money. And once you've got all these ISPs in the same place, then it starts to create other interesting things in that there's a competitive market for buying and selling access capacity, wholesale internet access, all kinds of things. So Peering is a very important building block of what makes the internet connect together. Two ISPs decide that I'm not going to buy or sell service from you, but we can both get advantages from having access just to each other's customers. So let's exchange traffic on that basis. And usually, unlike buying service from somebody, there's no money changes hands. And it's what's called settlement free. When two telephony operators interconnect, then the money tends to flow in the direction of who's making the one call to the other. Peering agreements between ISPs, generally there's no settlement. It's not unheard of, but generally there's no settlement when you're exchanging IP traffic. And it's about bartering perceived equal value. And you will quite often get the situation where a big ISP will say, well, I'm only going to peer with other big ISPs, and here's my set of rules for what is a big ISP. And they won't peer with the little guy, but the little guys will peer with each other, and there's a whole kind of food chain. Not billing the packets also keeps the commercial arrangement simple. You can quite often get a peering agreement on 2 or 3 pages, or it's quite often done on a gentleman's handshake basis. Other key principle is that of public interconnect. I refer to an IXP, Internet Exchange Point, throughout my discussion. More commonly in North America, they're called NAP. Easier to pronounce but less technically accurate, network access point. But when I say IXP or NAP, I mean exactly the same thing. The point here is that you have a single shared fabric that everybody's connected to. It's usually Ethernet. There are other technologies that work as well. But it creates an open medium in which many-to-many connectivity becomes possible. That doesn't mean that you have to exchange traffic with everybody else on the exchange. What it means is you have the possibility of doing so. Actually exchanging the traffic requires a bilateral agreement. Other models exist. I talked about private interconnect earlier, and I'll say a little bit more about transit shortly. Technologies, back when people first started doing this, 10 meg Ethernet was the most common thing. That was used to connect the ISP's routers to a switch. At the bigger exchanges, we had more than one switch. We used 100 meg FIDI. But usually most of these exchanges were one switch in one building. 6, 7 years ago, 100 meg Ethernet came along, pretty much superseded all the 10 meg and the FIDI. Few exchanges used ATM. Ameritech ran a big exchange in Chicago that was ATM based. I think was the most successful of these. But 1 gig Ethernet is now pretty ubiquitous. 10 gig Ethernet, a lot of the exchange operators were very much the bleeding edge of 10 gig, and there was some that was more painful than it needed to be. But typically it's used in the core of network, between the switches, between the sites. But at the bigger exchanges where they're pushing maybe 50, 60, 100 gig of traffic, the 10 gig is quite often used to connect the actual members to the exchange as well. That's scary because there aren't any technologies that are going to be a whole lot better than 10 gig anywhere obvious. And that's a separate story. One way of bodging around the 10 gig limit is to use things like WDM, MPLS, other kinds of bandwidth multiplying technologies. Gigabit Ethernet is good stuff. It's cost effective, it's high bandwidth, it's cheap, gives you more capacity than most users or SMEs might ever want to use. Very common now. It works between one rack and another over copper. It will work over metropolitan distances, tens of miles, kilometers. Most ISPs use it. It's almost universally used to connect switches together. And really, if you go out and buy a switch now, the price premium for a port that will do 1 gig over copper compared to 100 meg over copper is negligible. And there's some good vendors, there's some good products out there. Cisco, Extreme, Force10, Foundry are all doing state-of-the-art switches that will meet internet exchange requirements, no problem. So, a little bit about internet exchange history. Been plenty of ageist remarks in the other room earlier on already. But we first started doing links in London in 1994. 10 years later, for the 10th anniversary, we donated the switches to the Science Museum in London. So if you're ever doing your tourist thing in London and you go to the Science Museum, which is worth visiting in its own right, then up there in their Digitopolis exhibit, there's a Ethernet switch that I cabled and labeled in a glass case, and so therefore it must be history, I guess. That was quite an interesting experience. As I said, set it up in 1994. Back then there were only 5 ISPs in the whole of the UK. I worked for one of them, Pipec. And literally there were 5 pipes out the country, and they all went to the US, and each one went to a different one. So if you were sitting in London connected to Demon and you want to send some email to your mate in Cambridge and Pipex, then literally it went from Demon across the Atlantic, across the May East Exchange in Washington DC to UU, and then back down the pipe to Pipex. Obviously that was silly, and these were the days when we were paying maybe $100,000 a year for 128K of capacity. So you can imagine that we had a pretty strong incentive. Of course, we were all fiercely competing with each other as well. So the idea that one of us would host the exchange and the others wouldn't was fairly alien. So eventually we found this nice building called Tally House, which basically just sold space. It didn't try to sell you anything else like circuits or connectivity. And we put a 10 meg Ethernet hub. I'm sure anyone who's got an Ethernet hub in their bag with them today has probably got more capacity, more capability than the original Link hub. But the important thing is we connected it all together first. We did the engineering, we got the traffic flowing, all the governance stuff, the finance, the legalities, all of that stuff come later. And I think that's a really important principle. History of links. This is not so different from a lot of other internet exchanges all over the world. After a year, we incorporated as a not-profit membership organization. We hired our first full-time employee a year later. By 97, we got 50 members. By 98, we were the first exchange to start going into multiple data centers and connecting them together. First exchange to deploy 1 gig traffic in 99. Got us up to 100 members in 2000. 2000, of course, was the dot-com silly year, but we decided to establish Exchange Point as a similar company, but on commercial principles in late 2000. Upshot is, around now, got the link traffic stats here. These guys are pushing 105 gig of traffic through the switch fabric, more than that if you count the private internet. So it's quite an interesting challenge to keep that stuff going and flowing. Bigger picture, what are internet exchanges like in Europe? Typically, the ones that have been successful have kept the neutrality model. They've set up a non-profit membership organization. They're not in the hosting or colo business. And usually, they buy space from people who run the building, so they just run the switches. There's lots of exchanges, but there's probably about 4 or 5 major cities, London, Amsterdam, Frankfurt, Paris, where there are big exchanges that are pan-European ones. So if you want to go from, say, Ireland to Italy, you might go via Amsterdam. If you want to go from France to Sweden, you might go via Frankfurt or London. So what they're doing is they're keeping EU traffic in the EU, whereas the original mission was to keep domestic traffic within a particular country. Most countries have a domestic exchange as well. In fact, a lot of them have more than one now. But the big guys are again, all pushing several tens of gigs of traffic. Landscape's a little bit different in the US. Most of the big exchanges are operated by data center providers. So there's people at Equinix who are NASDAQ listed, the Switch and Data who have got a facility in Cleveland amongst many other cities, Terramark down in Florida. And their primary business is selling space. They're certainly not in the ISP business because the ISPs are their customers and they don't want to compete with them. But generally the exchange, like Equinix call them IBXs, they're run as just one more service within that data center. It's a way of attracting people to the data center and extracting more money from them. Again, there's a focus on particular cities that are doing the national and international switching, San Francisco Bay Area, Washington, D.C., originally May East, various other things now, New York, Chicago, Los Angeles. There's also quite a number of, there's a few other cities like Miami, Atlanta, Seattle, where there's quite a lot of traffic switched as well. But there's lots of little ones as well, which for the sake of this presentation, I'm going to call regional ones. Slightly different ball game there. Typically volunteer membership organizations, pretty informal governance. Mostly it's local ISPs rather than sort of backbone tier 1 type people that have got together. Consequently lower traffic volumes. As I say, there's lots of them. The two that are physically closest to where we are today are in Pittsburgh and in Columbus. And these are the ones I'll talk about a bit more later on. Again, global perspective on the regional internet exchanges. There was a kind of second wave of these in the late 90s. after the national and international ones had set up. Some examples that I've been involved in, Manap in Manchester in England, Scotix in my hometown of Edinburgh in Scotland, the HH in Hamburg in Germany. And quite often there was a sort of motivation behind these, which is that there's far too much centralisation of the infrastructure in this country. Let's not have all our traffic going down south to London and back. Let's stop it up and open it in a local exchange. Again, not just the tier 1 guys, much smaller, more universal participation. Quite a lot of local government kind of jumped on the bandwagon there. It's like, oh well, we've missed out on the dot-com boom, but we can catch up if we just have our own internet exchange. That's a blessing and a curse. Again, say a little bit more about that. But really, like a lot of things that boomed in the late 90s, not all of these survived. Okay, a little bit about the non-technical stuff, the commercial and governance models. Neutrality is really very important. The whole point of internet exchanges is one place in the region or the city that you go to connect. If you get several of them in the same city, then you have to go to multiple of them, and then it costs more, and then you've lost the advantage. So they're kind of a natural monopoly. Which means, of course, that whoever gets to control this monopoly is in a position to abuse it. So there's lots of risks if you don't set up the governance right, that it's not neutral, that there's abuse by one party or conflict of interest. There's some principles there. Successful internet exchanges, they're generally not owned or operated in-house by a single ISP or carrier. That's not to say there aren't examples of it working perfectly well. They're not transit providers. They don't resell IP connectivity to the rest of the world. They only enable connections between their participants. And they're not national or international backbone. Quite in less developed internet markets, Middle East, Asia Pacific, there are quite often things called the blah internet exchange, but actually they're not internet exchanges. They're actually the national PC telco has got a monopoly on internet transit, and they're calling it that because they can. Co-location, the actual building you're in, having that neutral is pretty important as well. In Europe, as I say, there's independent commercial companies who are purely in the business of providing space. In the US, they're tending to run the switch fabric as well of the exchange, but again, that doesn't have to be any less neutral. One place, carriers do a lot of colo, sell space to the customers. The idea of putting an internet exchange inside the telco jail is just one that's not at all popular. A bit more about neutrality principles. You don't have to comply to all of these to have a successful internet exchange. If you don't comply to any of them, you won't have a successful internet exchange. What works is very much tailored to the community that it operates in. But don't keep your members, treat them all the same. Don't get into the business of long distance or international backhaul or carriage. Don't go into exclusivity with various parties. To say, don't be a wholesale ISP. Don't step over the line of being on a wholesale ISP by sharing in somebody else's revenues. Don't connect outside the metro area. Confine for the service that you have to just the colo sites, and don't get into the business of running local tail to every building in the city. Being in multiple colo sites is usually okay, but that can be politically quite sensitive. And again, previous speaker was talking about differences between Germany and the US, and we had no problem. Well, we had some problem connecting our sites together in London, but the German exchange operators, I know, have had a very long battle in getting out more than one site. There's lots of different models that apply. In Brussels, Lisbon, Catalonia, the National Academic Network runs the Internet Exchange, and that works mostly fine. I've talked already about the not-for-profit membership organisations. That's by far the most common model. I've talked about Links in London. Another very large and successful one is AMSIX in Amsterdam. I think the most successful North American membership exchange is Seattle. Or the commercial providers. Another model is you actually have a company, but the shareholders are some of the exchange members, like the Mix in Milan or the JPIX in Tokyo. I have this principle which I apply, which is that the internet survives on a balance of competition and coordination. Too much competition and you get a whole lot of proprietary standards, nothing interoperates. Too much coordination and you finish up with monopolies and centrally planned economies which stifle innovation. I think this applies to governance models, the environment the internet exchanges work in. There are advantages and disadvantages. Commercial ones can be very flexible, which is something new. We don't have to take the members in order to get authorization to engage in a new project. They can maybe ride some of the short-term market blips a bit better, but there's always going to be pressure on them to be less neutral, to go after the revenue opportunities. Non-profit ones work very well, but they do need a certain critical mass to be viable. Volunteer ones, well, they don't use a lot of resources, but they can sometimes be a bit opaque. How do I join this exchange? Oh, well, you have to try and track down this guy who's impossible to reach, whose name's not on the website. And they're captured by, maybe one volunteer will do so much stuff that they feel it's their personal property, or they're also subject to just apathy. Nobody can be bothered volunteering. They've all got day jobs. Public sector ones can work very well. Again, they're less common. There is a monopoly danger there. There is a danger of them being hijacked by political influence. Okay, so you've heard the first part of the talk. You think, well, one of these internet exchanges, maybe I could have one of these. How do I could be cool. How do I go about setting one up? First step is you've got to have some critical mass. An internet exchange with one ISP at it is not really any value. Experience suggests that 5 is the magic number. If you get less than 5, then it's probably not worth doing. It won't necessarily be self-sustaining. And of course, because all these people will be in the same physical location, they will potentially be in the same market, they will compete with each other. Depending on how cutthroat that competition has been, getting people to trust each other in an environment like that is not easy. Generally what you need to do is you need to get all the technical people in the room together and sort of lock up all the salespeople, and then you can usually identify common benefits that will get people to trust each other and get the thing going. Quite a good idea if you're setting up a membership organization, association, have some kind of memorandum of understanding that everyone signs up. If you're starting a commercial exchange, you're running it as a company, the principles are a little bit different. You can use like discounting strategies. The first 5 people get it for free, the second 10 people get it for 50% off to encourage people to come on board. And that can work reasonably well. But as I said, I think the focus is get the traffic moving first. An internet exchange that doesn't have a traffic graph on its website is not a real internet exchange because it doesn't have any traffic. It may have some wonderful website with all the stuff about governance and all the wonderful events they've had, but if they're not actually shifting packets, it's not real. Do that first. You're running an ISP, you want to connect to an internet exchange. What do you need? Well, the key thing is you need your own autonomous system number. And that's something that you need. If you're taking transit from more than one ISP, you connect to more than one upstream, you need an AS number anyway. You need your own provider independent address space. By far the most straightforward way to that is to get that. Not for everyone, is to become a member of an internet registry. Body that does that is the American Registry for Internet Numbers. They're meeting in Montreal over the next few days. South and Latin America, it's LACNIC. Europe, it's RIPE-NC. There's 2 or 3 others. Other thing you need is Box can do BGP. Most Cisco and Juniper routers just do this out the box. You can buy kit from other vendors. I'm not so sure that their BGP implementations are completely up to scratch, but if that's an issue, there are some good open source Unix BGP implementations. Software like BGPD, Quagga will certainly do it. You need to put bots into a colo facility where there is actually an internet exchange. Once upon a time, it was really expensive, and you had to spend like $10,000, $20,000, $30,000 to connect to an internet exchange. These days, you can buy the box off of eBay. You can get personal colo space for $50 a month, something like that. And some people have strange hobbies. My strange hobby is I run my own AS. Just to prove it, here's the entry from the RIPE database, which says what my routing policy is in terms of what other AS I connect to. And so, as I said, it's a slightly strange hobby, but it's within the means of most ISPs these days to connect to an exchange. So basically, you want to set up an internet exchange. It's not rocket science. People have been doing this for ages. Lots of help available. Good resources. EP.net website lists all the internet exchanges in the world by continent. Packet Clearinghouse are a great organization, non-profit based in California. They do a lot of outreach work to developing countries to help them set up their internet exchanges. European exchanges are a very strong position. They've had enough resources to set up their own association called EuroIX, which again does a lot of work helping new exchanges get set up. Another European body, RIPE, that's been around for a long time, has a working group that's specifically dedicated to internet. Okay, security. I'm not a security expert, but it struck me that this is a topic that's liable to be of interest to this audience. The biggest issue in internet exchanges is you've got a common, which is basically shared by everybody. Typically it's a single Ethernet, typically it's a single subnet, and when you've got boxes that are under different network management domains that are being connected to that, there's certainly the scope for some interesting things to go wrong. Very early history of internet exchanges, they would be a dumb hub, or they would even be old-fashioned. I don't know, is there anyone old enough in the room to remember yellow thick Ethernet cable? But the point is that it's a common medium. If you use that kind of technology, it's extremely easy to wiretap, and if you're party C and parties A and B are exchanging traffic, it's very easy to tap into that. Typically, these things are not encrypted. Ethernet switches came along. They made life a whole lot easier, a lot more safer. That's not to say that they don't introduce risks of their own, but clearly Ethernet switching, at least you get away from the wiretapping issue. What are the things that can go wrong at internet exchange? Broadcast storms are by far the worst. Associated with that, connecting layer 2 switching devices so that the Ethernet switches aren't just owned by the exchange operator, but by third parties as well. Switches don't always do what it says on the tin in terms of switching the traffic to the right port. Broadcast multicast traffic does not scale well. Too much of that and you're in trouble. ARP traffic is a necessary evil that has risks associated with it. There are various evil things that can be done with static routing and mucking about with BGP NIC pop, and also some risks of hijacking the routing resource. Broadcast storms are pure hell. I think I can say that some of the worst hours that I have ever spent in my 20 years of network operations have been caused by layer 2 broadcast storms. And this is basically where somehow a loop gets introduced. Maybe the spanning tree that's supposed to prevent loop detection on a layer 2 Ethernet fabric fails. The broadcast packet just keeps circulating endlessly. A lot of internet exchanges actually don't use spanning tree precisely because of this. It's not a particularly great protocol. There are proprietary alternatives, but quite often the alternative is you keep one link down and you manually enable it if the other links fail, but otherwise, because you can restore the network more quickly that way than you can repair the damage of a broadcast storm. The single biggest cause of broadcast storms is people connecting their own Ethernet switches, extending the layer 2 topology without you knowing about it, not knowing what they're doing. So it's quite difficult, but it is essential to try and be fairly Stalinistic about what kind of kit people connect and how that interacts with the other kit. But a bad broadcast storm, not only does it shut down the entire IXP, it can take several hours to recover from that, it also makes root cause determination very difficult. You've got not so much a smoking gun as a smoking pile, and it can be quite hard to figure out exactly who caused it. Other problem with broadcast traffic, it doesn't just harm the actual switch fabric. Broadcast packets usually get handled by the CPU and routers, can burn a lot of CPU resource. Not only does that affect it can affect the BGP process in the router, which causes root flap across the internet. It can have some quite substantial knock-on effect. So, what causes switch containment failure? Switches are supposed to only forward stuff with a particular destination MAC address to the port that it belongs on. A few circumstances where this breaks down. Certainly software and hardware failures cause that, which are more or less common depending on how reputable your switch vendor are. Cheap switches, the kind of thing that you would buy in Micro Center or Fry's or somewhere like that to connect your home kit to. These generally are not designed for industrial strength. They'll have a limited content addressable memory table size. If you actually introduce traffic into that switch that's too many source addresses, it fills the CAM up. What does the switch do in that? It just reverts to being a hub, and it forwards all traffic to all ports. So you've lost the security of being a switch. Best way to avoid this is don't use cheap and nasty switches for internet exchanges. If the switch vendor also happens to sell cables and washing machines and DSL routers and stuff like that, then probably you don't want to buy one. You probably want to buy it from someone whose business is like doing switch manufacture, router manufacture. The better ones don't just do the MAC switching destination port right. They can also do things like only limit the number of MAC addresses per port to a specific number, or to do other kinds of filtering. Problem broadcast traffic. As I say, really the only broadcast traffic you need, the only thing you connect an internet exchange is a router. If you get a router connected, the only thing that you only need to broadcast stuff between these routers is ARP. If there's anything other than ARP, if there's more than a few ARP packets per second, that is abnormal condition. If you don't do something about it, something bad's going to happen eventually. Likewise, there shouldn't be any layer 3 IP broadcast traffic. I mean, that is wide open to Smurf attacks anyway. But there's a whole bunch of protocols like DHCP, SMB, BIOS, internal gateway protocol, internal routing protocols, device discovery. Again, it shouldn't be there. ARP is a protocol where there's spoofing abuse possible. Some IXPs actually insist on hardwiring the ARP to IP address mapping. Others use more advanced filtering techniques, depending on how much clue the vendor managed to absorb over the past years of this kind of stuff. You can't always trust an ISP, to be honest. When it comes to interacting with other ISPs, there's some bad guys out there. I hope there are less bad guys than there used to be, but you know, sometimes exchanges have had to do stuff to check out ISPs or spammers, for example. But default dumping, I'm just going to dump all my traffic on this other guy across the exchange. He's not going to know about it, but I'm going to get free outbound traffic. Or you can do that for particular destinations. Maybe there's somebody who's used to share with you, but you really need to get to one of their sites. Nixtop spoofing, BGP advertises a Nixtop destination address. You can change what that Nixtop is, and that can cause some curious things as well. The worst abuse case that I had to deal with was this dodgy ISP operating out of London, who basically connected to our exchange, connected to one of the big exchanges in the US, set up some static tunnels, and was basically had a website that said, "Oh, we are a major international transatlantic infrastructure player," and actually they didn't. They were ripping off 3 other people's bandwidth. So that was an interesting exercise that resulted in their kit being seized by Scotland Yard, and I don't ever want to experience dealing with that kind of thing again. Other kinds of routing abuse are much harder. Most BGP sessions are MD5 detected these days. So, okay, there's lots of stuff that can go wrong. How do you prevent and detect that? I think it's very important to have a clear policy for what is and is not acceptable practice. People know what the rules are. There's a whole bunch of documents out there, a couple I've been involved in writing, the URLs there. But it's not just about having a clear policy, it's also about monitoring that that policy is complied with and enforcing it when it doesn't happen. There's custom software called IXP Watch being written, which just sits and looks at all the broadcast traffic in Exchange and use that to figure out whether things are working properly, whether there's strange stuff going on. You can use Armon to actually look at the packets on the wire. NetFlow and SFlow that actually tell how much traffic is being exchanged between a pair of destinations or between a pair of ports can be very useful for picking up strange stuff. In general, routers that are dedicated boxes are much easier to secure than connecting a general purpose server. Once you connect to a general purpose server, that box gets owned, then there's all kinds of things that you can get up to with it that would disrupt the exchange. That's not to say you can't do evil stuff with routers that are on dedicated boxes, but in general it's harder. Some exchanges actually have rules that say you cannot connect general purpose servers. And again, a lot of these accidents are prevented if you just smart about the switch filter hygiene. Okay, I wanted to talk a bit about regional internet exchanges. These are more challenging. Once you've established a need for a large exchange and built up critical mass, then all you have to do is cope with the 90 gorilla of traffic growth. You want to set up a regional exchange, it can be more difficult. My experience, one of the single biggest problems is that most of the eyeballs, the people in the DSL connect, cable connect in any given metro area, are locked into 2 or 3 MABELs or cable operators. Generally, they will do their peering, their exchange connection centrally, somewhere over on the west or the east coast or Chicago or somewhere like that. And there won't be either the people with the administrative decision-making power or the technical clue in the local organization to necessarily connect up to an exchange within a given city or metro area. Sometimes there's issues with the infrastructure in terms of finding a site that's both neutral and both quality. Maybe all the data centers are owned by the ISP itself, or maybe the common facilities aren't up to industrial strength standard. Sometimes there will be a lack of competition in the market, and actually buying local books at sufficient capacity from the local ISPs up to the city's internet exchange will be expensive, and that can create a barrier. Making sure there's enough technical glue to go around. I mean, it's not hard, but there is an education process quite often needed there. BGP 101. Sometimes the entry-level technical resources can be an issue. That's more of an issue in developing countries. It's very much less. As I say, you can pick up all the kit you need off eBay these days for a few $100. It's much less of a problem than it used to be. Political interference. I have come across local politicians who, as I say, see the internet exchange as a way of forwarding their career and looking high-tech, and actually they do very little in terms of the real getting the traffic on the wire that's necessary. But one of the biggest challenges, and one that's caused failures, cost of transit. In many ways, it's a good thing, but since Y2K, the cost of buying wholesale transit has dropped from hundreds of dollars per meg per month to less than 10. You have to shop around, you have to buy in bulk. You can get internet transit for less than $10 a meg a month. The whole of the code is consolidation and commoditization. What that means is that money you can save from peering is less than it used to be. 20% of your traffic can be saved by peering. 20% $10 is a whole lot less than 20% of several $100. But there's a fixed cost associated with the connection and exchange. So these days there's less money to do it. The large IXPs, obviously you've got a volume of traffic there, that you have the critical mass to survive. But if you're a regional player, the second exchange in the city, that can make life a lot harder. I mean, unfortunately last year there was an exchange in Cape Town, the main South African exchange in Johannesburg. The one in Cape Town was non-profit. Hit cash flow problems, had to lay off all its staff. They have to do something similar in Manchester, although I think they're recovering from that now. So there isn't a completely economic case. What are the other benefits? Once you've got this place in the middle, which is where you put your internet infrastructure and it's got high bandwidth and low latency, then there's a lot of incentive. It's a good place to put resources, things like top-level name servers, secondaries for .com or .uk or .us or whatever. Time servers, we had all that fun at the links in Y2K. We managed to get sponsored for 3 atomic clocks. So we put a 3 atomic clock on the Greenwich Meridian line. So the 0 degree line went through the building, and that was the Greenwich Electronic Time Project, which was fine until the politicians hijacked it. That's another story. You can do things like performance measurement tools, academic research projects, monitoring how the internet performs, how traffic flows across it. These are all good things to put at exchanges. You can enable new applications. You've got high bandwidth, you've got low latency. Always it improves technical coordination knowledge here and get technical people, different ISPs interacting and learning from each other. You can create a centre of expertise for internet technology, local to the region, and it's also good for coordinating security stuff. Generally, you fairly fast human communication centre around an exchange to deal with bad guys. Other advantages, you can increase diversity and resilience. Maybe you're an ISP, you can only afford one upstream transit, you connect an internet exchange, maybe do a mutual backup arrangement with another ISP who's got a different upstream. Reducing latency I've already mentioned, but I mean, that's particularly important for gaming and multimedia. Getting that delay down, doing real-time stuff. Again, the medium is very efficient, many-to-many medium, which means that multicast applications work very naturally across exchanges. It's very efficient. Internet exchange get into the business of doing other Ethernet services. Sometimes there's competition sensitivities there, but you can do point-to-point, point-to-multipoint Ethernet service. But I think the important thing is you're building a stakeholder community. You can quite often use that stakeholder community for other things. Probably you want to ring fence or Chinese wall the trade association activities from the actual running of the exchange, but that can be, again, quite a good way of doing technically clueful lobbying. Other roles for exchanges, you can create a market of buying and selling transit and other services, so that you have you can maybe encourage other transit providers, wholesale providers into the region to sell services, whereas if you're selling them one at a time, it might not be. If you have a regional academic research non-profit network operator, then it may be a very good way for them to handle their external connectivity and not have lots of ad hoc arrangements. We did some other interesting other stuff in London. Unbundling DSL. You want to resell DSL, the carrier will quite often require you to get a big fat pipe. Maybe you're not a large enough ISP to do that. We actually had ISPs who were big enough to buy their own pipe, ATM pipe from the telco, and then actually resell fractions of that over L2TP tunnels across the exchange fabric. And other things, just acting as a local loop. There are some players like Packet Exchange who are in the business of doing international Ethernet circuits, and they like using it as a local loop so much well they bought the company, but that's again another story. Why do internet exchanges fail? Inability to be reliable or to cope with growth. It's one thing to start, it's another thing to keep this thing going. Making exclusive arrangements. Okay, I'll just try and wrap up. Exclusive arrangements with polo providers who go out of business, that's what screwed up the exchange in Edinburgh. Not building critical mass. I'll skip over this stuff. Summary. Building an internet exchange is not hard. Resources to do it are widely available, lots of people have done it. There are some cost benefits, but there are a lot more intangible benefits. The hard part are building the critical mass, keeping it viable, coping with growth and abuse. But it's all about sharing with others. That's my experience, always educational and fun. Maybe someday every city will have internet. Anyway, there's my contact details. You can get a copy of the presentation and catch up on these few slides that I had to skip over. I hope that was useful or interesting. Happy to take any questions. One question back there. No, I connect to an exchange. In Cleveland? Not to my knowledge, no. I mean, I don't think that's an initiative that's been done. I know that there was an initiative in Dayton called the DMIC, but I don't know what's happened about that. As far as I'm aware, there's an exchange in Columbus. I think there's another one in Cincinnati, and then there's the one in Pittsburgh that I mentioned as well. So yeah, I don't know. Maybe Cleveland could do with its own internet. Yeah. These were kind of abstract diagrams. In general, the topology that most internet exchanges will do is some kind of ring. You can either run, you can try running spanning tree around that, and as I say, that comes with some health warning. Or there are various proprietary technologies for, marking down one link in the ring, and then if it breaks. But in general, you'll have a core, which is probably a ring. Maybe have two spurs off that for satellite side, and then the ISPs all connect into the edge of that. I'm sorry, I didn't. You can pretty much do it for nothing, because you'll probably find some switch vendor out there who's so keen to be associated with an internet exchange they'll lend you a switch for free. And whether the switch is any good or not, I don't know. But you need about a rack worth of space, which cost you a few thousand a year. You need a half-decent Ethernet switch, which, depending with buying new or off eBay, will cost you a few hundred or a few thousand. And then most of the other costs are for the ISP participants. They need to hook up to that. They need to have the circuit into the building. They need to face the route. So yeah, it can be done reasonably cheaply. Okay. Oh, yeah. Um, that's a very interesting question. Part of what's driving that is that peering arrangements quite often happen in the business between what we call eyeball providers, DSL and cable, and in fact, people in the end of them, and content providers. And obviously, AT&T is now big in the eyeball business, whereas the like Google, Yahoo, broadcast stations, people like that have a lot of content. Because the likes of Google have so much power in the market, they have been very reluctant to enter into peering agreements with anyone unless there's something in it for them. So this is obviously AT&T trying to use its new muscle to turn the table on them. I suspect that the market will probably balance things up there. There have been some attempts to do regulation of the settlement, the traffic exchange between ISPs, but in general, it's something that survives reasonably well. It's something that regulators like the FCC or Ofcom actually don't understand terribly well. So I hope that one will play out sensibly, and that I don't think that actually quality service is very meaningful in these environments, because if you've got 100 ISPs with 200 peerings at an exchange, are you then going to multiply that by 4 different classes of quality of service? I think that's too complicated. So I think it's cage rattling. It will probably play out. But yeah, it's an interesting question. Okay, thank you very much. Thank you. My wife